Before I get into today's topic, I want to finish up yesterday's and just kind of point out a few little things about that. Um, so we were, and by we I mean me, um, kind of doing the snakes and ladders game because it's a nice illustration of using a number of different objects, a number of different classes, the instances of which have their own responsibilities, and that's kind of the payoff on this object-oriented stuff. Kind of before the object-oriented stuff, or in other situations, you basically just have one file, and you just sort of start at the top and you just kind of execute line by line until you're done. And in a way, that's still the case, except that only happens in the main method. So in the main method, you start at the top and you work your way down, and when you return from the main method, the program is finished. But in the meantime, what happens is objects are sending messages to each other about this, and well, this is a good illustration of that. So, and what I did was I finished implementing it, just so don't have to kind of sit there and watch me do my lousy typing. But one of the key methods is this one in the game board where it says where you move the player piece by rolling a die and then trying to move. So you roll the die, and we can get the current position. Okay, the piece, or I think the book calls it a counter. I don't just remember the current position is the board square, but the board square has knows which index it is. So we want to know which index it is so we can do the counting, because I can't add a number to a board square. That's apples and oranges. So this is an example of sort of multiple message passing, and this is kind of my my C things coming in, because it's this kind of violates some of the things that I talk about, where I say, well, this would be better done in stages. So this does two things. But I send a message to this piece that says, give me your current position, meaning the board square. Actually, a better name for that method would be get current board square. And then the position of the board square is the index. So basically what I'm after is I'm after the index of where the piece is currently. And then the next position, which is sort of might be better named tentative next position, because now I'm going to add the die roll to my current position, and it's tentative because of several things. One is, well, if this results in a square that has nothing in it, then I'm going to, well, first I say, well, if it's less than the length of the array, which means it's a legitimate index. So this is the off by one business. So if the length of the array is 100, and my next position is less than 100, that means it's going to be a legitimate index. But if it's equal to 100, then that's too much. So first I'm saying if my quote next position is going to actually land me on an actual square, so let's get that square. And where's the square? The square is in the squares array. And now I say, okay, I can actually move there. And then here, okay, so here's, in lieu of the print line, I'm using this logger thing that, and I'll show you why logger is better than print line at some point. Okay, so we're saying, okay, now we're going to move to this square, but then there are two possibilities, three possibilities. One is, if it's a blank square, then we just sit there. But if it has a snake, then we kind of slither down to the tail of the snake. So how do we determine that? I say, well, if remember I added this has snake method to the board square. So if you have a snake, then get the snake and then slither down to the head. And how do I do that? I do another move to, now I'm going to move to the tail. Otherwise, if it has a ladder, because it either has a snake or a ladder, and we, if you remember, the board square kind of enforced that. The book didn't kind of do that well, in my opinion, because the book left it open for the possibility of having both a snake and a ladder in the same square, which isn't, you know, as you can tell, it would be ambiguous, because if I land on one that has the head of a snake and the foot of a ladder, do I climb the ladder or do I slither the snake? That's okay. So one or the other. So if it has a ladder, then I'm going to climb to the top, and I do that. And then if it's neither, then I just kind of bop through. Now, if it fails this test here, meaning that I can't land on an actual square, that means I'm trying to move beyond the last square, which means that I'm not allowed to do that. You know, so if I try to move beyond, then you lose your turn, and then because I have to land exactly. And so I'm going to log that, and I'm going to log that as a warning. I don't know why a warning. Usually a warning is like kind of programmatically, it's kind of more like, hey, it's not exactly an error, but it's like it's a little sketchy. So. Okay, now there's the book actually put the main method into this, which to me is not a good design, because I think it's a better design to separate your components from your main method. The main method is just kind of runs things, and your components are something else. So for me, for the book, Snakes and Ladders class was also the main, and I left that out here. So. It has a game board and a player, and so we kind of set the player from this and instantiate the game. So the game board is kind of owned by the Snakes and Ladders. That's the, I guess you could call it composition, or again, they're all associations. So how do we play the thing? Well, we're going to first move the player to the start square, and then we could do this either as a while loop or a do while loop, but while the current position is not equal to the last square of the game board, then we're going to move the player base, and that's really all it is. And then when we bop out of this, then I'm going to log and say that we won. Okay, so here's the main method. And I did this in pieces. So it's like while testing it, I kind of hard-coded in where the snakes and ladders were, as kind of the book did, but the book did it in kind of a sketchy way, in my opinion. So here I had and this also ties in with what I was talking about yesterday about a static method. So here we are in main. Main is a static method. If you remember, one of the very first things we did with Hello World, we said public static void main, and now you know every piece of this. Okay, at the time it wasn't clear what the heck those words meant, but now you know what they mean. Public means it's accessible to anybody. Static means that the method is associated with the class. It's a class method, and void means there's no return type. Okay, so I'm going to instantiate a player piece. I'm going to instantiate my snakes and ladders with that player, and then I'm going to configure the game board. I'm going to circle back to that. Then I'm going to do the play, and then one of the things I added was that each player, I added sort of a number of steps. So what I'm going to do is every time I do a move to, I'm going to increment the steps. So it tells me how many steps did it take. So now to run this for reasons that I'll kind of show you a little bit. You see this little drop down up here? So that's something where I can customize different ways of executing this. So I created a a configuration. I called it, snakes and ladders. And then what I can do is I can browse to the main class. In this case, I chose this, so I selected that as the main class. And then these are other options that I can give it. But what that does is that allows me to run the program by hitting this little green arrow. So there's the little threading thing. All right, so now this is one of the outputs that you can get. So these are the outputs from the logger. So here's a log where the purple rolls, and then and it's a little bit verbose. The thing is that you can make this less verbose by creating an XML file that it reads. Again, that was kind of a little bit of a bridge too far. So it looks a little bit messier than the other, but all the information is there. So so here we have purple. It rolls a 1. It moves to the board square 1. If it rolls 3, moves to board square 4. So we can kind of make sure that the rolls are working right. But then here we land on a ladder, and then we say, okay, we're going to climb the ladder from 27 to 83. And then we land there, and then keeps going and going and going. And then here we wound up toward the end at square 98. And then we rolled a 4, which would have brought us to 102, but there we get the warning. So these are all the stuff in red. These are all the things that were created by the logger thing. So here we said we finally got to square 99, and then we say, in this case, it took 28 steps. All right, so now, the initial impression is, well, wait a minute. Why is this better than a print line? Because with a print line, I wouldn't have all this other garbage. And that's true. But remember what I said about there being there's no such thing as a trivial edit. And it bears repeating that if I have a component and I've tested each component, and the component has been verified, meaning that it has been implemented according to the way it was designed. What does that mean? It means that all of the methods are working exactly as they should with all the different possible inputs. And once I have something that's been verified, if I touch it, if I change it, then all of a sudden it's not verified anymore. So if I have to go in and comment out print line statements, then I've done editing. And if you're like me, it is all too easy to accidentally delete more than if I go and either comment out or delete the print line, then it's just too easy to delete more stuff, but regardless, you've edited the file, and then now it's not verified anymore. So how do you verify it? Well, you have to turn the print lines again. So you see the catch-22. You say, well, how is this better? Well, this is better because I can turn this off without having to touch my components. So back here in the main method, this is where I'm doing it. Now the logger mechanism, which I'm not going to go much more deeply than this, it's actually a very sophisticated hierarchical way of letting you know what's going on. So like all this extra stuff here, what this is this is a timestamp, and it gives the method. So here, this is game board. The method is move player piece. So, and if there were other methods where it was being logged, then it would also report that. So in other words, this is giving me a lot more information than a print line, unless I said in the print line, hey, I'm in this method. Logger automatically does it. Okay, so at the top of the hierarchy, there's something called a root logger. Actually, when we create our logger, notice that I'm giving it the name of the class. And that's what tells the logger where things are. And so each of these are a separate logger objects, and they actually all are in a hierarchy with this root object that's the source of everything. So what I can do is I can set the log level of the root logger to something that basically turns it off. So now, but by default, it kind of gives stuff with info. But if I tell it to, okay, so okay, just sort of backing off. Okay, remember we said I know everything about public static void main. Okay, what about this array of string arguments? What is that? Those are the command line arguments that you give after you invoke the program. So if we're running this on the command line, then you would say, Java, give the name of the class, and then maybe put extra stuff. And all that extra stuff is put into this string array, which comes into your main method. Now in NetBeans, that is right here in this arguments. So I can put an argument here, and my argument is going to be my new level. So if I have, let's see, I have to remember what they are. So if I say, I think severe message is, if I say, okay, I only going to log severe messages and worse. That's what I'm telling it. And so what's going to happen is, what I'm doing here is I'm saying if arg's length is bigger than 0, if there's something on the command line, then I'm going to get the root logger, and I'm going to set its level, and what I'm going to do is I'm going to parse what I wrote there. I'm going to put it to uppercase because all of the levels are listed as uppercase. And so now if I run it like this, I don't get all that red stuff. I just get the one, I think I put in here, in my main method, I put a print line. Why? Because in main methods, that's not a component. So print lines are okay. So I've turned off all that verbose stuff and just have whatever information I want. So here it took 66 steps. Ran the program anyway. And if I want to turn it back on, I can either change this, or I can, if I just change this to info, for example, then it's back on. Okay, so, and what's the, again, it bears underscoring. The value of this is that I can turn these messages on and off without having to touch my components. And that allows me to verify the components, that is, they're working properly, and then either go through in a verbose mode and sort of see everything that's happening, or turn it off. In a large program, that makes a big difference, because in a large program, the logging, I can, how should I say, it's like I can, there are levels like fine and others. I can actually create custom levels so that only certain things get logged, and I can actually specify all that outside of the components themselves. So that if I'm running a large program, I may be interested in some, but not all of the output. Okay, now the final thing, a couple of design things here. Let's see, where did I put it? Okay, so in the game board, how do you get the snakes and the ladders in? Well, here again, this was a choice. This isn't the way the book does it, but what I said was, okay, for the game board, I want to be able to add a ladder, and I'm going to tell you what the top and the foot is. And so when I'm going to add the ladder to my squares when I call this. The other thing that the book also doesn't take care of is, what if I specify a ladder where the foot is above the top? In other words, a ladder, it's not a ladder, it's a snake. So, okay, so that would say that's illegal. So if you try to set the foot bigger than or equal to the top, that's not a legitimate ladder. And so if you try to do that, that's bad data. And so I want to say, hey, no, you can't do that. So what that allows is, well, the first cut was, then I wrote a static method, and it had to be static because I'm calling it from a static. If I'm calling it from main, main is a static method. I can't call an instance method from a static method directly. I can invoke an object, a method on an object. So for example, when I say snakes and ladders play, I'm not invoking play directly, I'm invoking it on the object. But if I want to call the method directly, like I'm doing here, that method has to be static if I'm in a static method. Okay, so here, this was just the hardwiring this in. I mean, the principle is you don't want to hardwire your data. You don't want to hardwire your data in your components. Now here, this was kind of an intermediate thing, like kind of before, while I was developing this. I said, okay, what I ultimately wanted is I want a data file where I'm going to read it in, because that way the code and the data are completely separate. And that's what you want in a program. But when you're testing it, sometimes you put in some scaffolding. This was basically some scaffolding just to test and make sure that that all of these things are working. But what I really want to do is I want to configure it from a file. So I'm giving it a file, and the structure of the file is as follows: is that I'm going to read the snakes in first, and then I'm going to read the ladders in. Now there are a number of ways of doing it. There are some fancier ways of doing this, but this is the most straightforward. It's actually not. There are better ways of doing it, but this is a reasonable way. So first, I'm going to read in. I'm going to create a scanner from the file, and first I'm going to read in a number that's going to say this is how many snakes I have, and so that's going to tell me how. Okay, I'm going to read in this many snakes, and I'm going to read in the head and the tail, and then configure it that way. And then when I'm done with those, I'm going to read in how many ladders I have, and then read each of those. I'm going to read a top and a foot, and then that's going to tell me what they are. So where is this thing? This is an example of the file. So here I'm going to read in 10 snakes, and here are the indices of the head and the tail, and here I'm going to have 9 ladders, and these are the indices of those. So when I do that, and then now this is a little bit of a feed forward because I'm using a file for the scanner. There's something there. A file not found exception could be thrown. Now, how can that happen? Well, what if I fat finger my name here? So if I fat finger this and I try to run the file, now it's going to, oops, that should not have happened. Am I really?
It is throwing the file not found.
Is it throwing it?
It's at the top. So one.
Ah, okay. Okay. So what happened? I fat fingered this. So here, and this is another feed forward. We're gonna look at interactions with the file system later. There's a really nice way of doing that. So for example, what I'm doing here is I'm getting the file using a relative path, and then once I have this file object, I can say, does that exist? And that's what this warning was. Say it didn't exist. That came up false. It says I went to look for a file. There was no file there. And in fact, the error message said, hey, this is, didn't find it. Why didn't it find it? Because I had that extra space there. And so now if I kind of run it this way, then it, here I had an info from that. It said, now this is the actual file that I'm reading from. Okay, so the couple of, I added a few extra sort of lessons here in designing your applications. Okay, one of which is don't hardwire data in your components. Yes?
What if you wanted the file to stop if the file path is incorrect instead of continue playing the game with nothing?
Yeah, so what,
Could you just like put a
Yeah.
return statement in that if to return out the main?
well, yeah, what I would do here is, since I have this hardwired thing, what I would, you're right, I thought about doing that, but yes, if it's, if it's not found, then what I would do is I would configure it using the hardwired thing. And that way it would run it with these guys. As it is, it ran it without any snakes or ladders. Which is how I ran it first before I actually created the snakes and ladders, because that was part of the development process. But you're absolutely right. That, the overarching principle is you want to be as user-friendly as possible. And, now if this were part of an actual kind of game, there would be a visual component, and if what you'd want to do is actually pop up a little file chooser and let the user choose the file, and that way the file would always be there. But, that's something we're going to cover later when we talk about graphical user interfaces. But, just some of the takeaways. Okay, this was our most complicated model so far. These are all the different classes that they had. So one thing is they were all related to each other, and so they were in their own package. So the thing with these packages, we've been kind of using this CS2173, a little bit of a dumping ground, just kind of putting stuff there. But in this particular, so here was the course example, and that was in its own package. The little gate example, that was in its own package, and now this is in its own package. And the idea is that here, for a fairly complex model like this, and it's fairly complex, you have a number of different actors, which are the different classes, and instances of those classes have different responsibilities. So the responsibility of the board square was to let you know whether it was empty or whether there was a snake or a ladder. The responsibility of the game board was to kind of keep track of all of these and move the piece according to the rolls of the dice and things like that. And they're sending messages to each other to make the thing happen. So that's kind of what the object-oriented, a big piece of what object-oriented stuff is about. Okay, the other things have to do with not putting print line statements in components for the reasons that I've harangued about, but using something like logger instead. The other thing is that in the process, we were starting to use this command line. And actually, one of the use cases that I use the command line for a lot actually is to identify what that input file is here. Here I hardwired in the input file in the main method. And that's kind of okay because the main method is not a component. The main method is I could create an entirely different main method if I want to configure and run the program differently, and I wouldn't have to touch any of the components. The idea is that the components are like a library, and once you have a library, I can use those components. Like in the process, for example, like this die class that we had here, that was not part of the snakes and ladders thing. Why? Because the die is something that we're going to use for a lot of different places. And that's something where, I mean, if we were developing a more extensive library, that might be in like kind of a util package where things that are going to be utilized by other components. But again, we're and then and then just reading information from a file. We're a bit later. We're going to kind of delve a little bit more deeply into getting stuff, and the thing is that thanks to the way that Scanner works and the whole thing happens, because this is working from a scanner, I can actually, if let's say I had the data on a web page somewhere, well, I could actually connect to that and create a stream connected to a scanner, and the scanner wouldn't know or care where the heck the data is coming from. In this case, it's coming from a file, but when scanner says next int, it doesn't know whether that's coming from the file, whether it's coming from the command line as we've done it before, or anywhere, just somewhere in the ether. Okay, so that's this example here, and I hope that it gives it gives you a sense of of the why question. I mean, surely there was a part of you that is wondering, okay, now why this object stuff? Why, and if you're like me, because when I said I come from, my origins were the Fortran world, and in the Fortran world you start at the top and you just kind of work your way to the bottom of the thing. And actually one of my colleagues when I was a graduate student was sort of trying to convince me that this object-oriented thing was the way to go. And I just sort of poo-pooed the whole thing. He says, whatever you do, I mean, I can do it in Fortran. So, and the thing about Fortran programmers is that a good Fortran program can write Fortran in any language. And I have to confess that my first object-oriented language was something called Objective-C, and I wrote Fortran in Objective-C. So I will confess to that. All right. Okay, so now on to today. So what we've been using objects just kind of with each other, and the next important concept is inheritance, and that is a way of it is not the only way, but is a way of implementing something called polymorphism, which is just a fancy name for saying that you can have, well, for me it's just, it comes down to a fancy word for the principle of ignorance and apathy. The other important concept is one of abstraction, and that comes up into play when we look at class hierarchies, because as we go down the class hierarchy, as we go up the class hierarchy, we go from a lot of abstraction to more and more concrete things, and we'll see what that is about. So I thought this meme was sort of cute. The object-oriented way to become wealthy is inheritance. Okay, so the big concept is that all of these everything you do in a program, and this is particularly relevant in simulations, and the context of this is the MOVES curriculum, modeling virtual environments and simulation. They're all simulations, and simulations especially are abstractions, and that not everybody gets that. You'll hear more rants about that in the simulation class, but okay. So recognize that the superclass and subclasses, like hierarchy, understand what that is about, how polymorphism is implemented using inheritance, And understanding which method in a class hierarchy gets invoked. I probably won't get to all of this today, so I'll probably this will probably have to continue tomorrow. And then how to override a method. So basically, abstraction is sort of taking a complex system and simplifying it so that we can understand it. When writing a program, we want to identify the important elements. And importance is in quotes, and we want to ignore the, quote, unimportant parts. That is very context specific, context dependent. Unfortunately, in a lot of the object-oriented articles, texts, whatever, act as if there's kind of only one way. And it's very context dependent. So for example, if we're modeling a clock, then some of the things that are important have to do with like, what time is it? And what time zone are we in? Things like that. It might be, is it day or night? Is it can be a 24-hour clock or a 12-hour clock? Things that are unimportant. What is the color of the clock? Where was it manufactured? What are its dimensions? If we're more interested in how it works, time-wise, then those are not important. On the other hand, if we're designing a clock that we want to manufacture and we want to simulate the thing, then some of these other properties would become more important. So, but one way of kind of looking at this in an abstract way is that we have kind of a hierarchy. So here's the concept of a clock. And what is a clock? A clock is something that's going to tell us what time it is. Now, if we're one way, not the only way, but one way of kind of saying, okay, well, there are kind of two ways that we can tell what time it is. One are mechanical clocks, and the other are non-mechanical clocks. Okay, what are some mechanical? We have an analog. We can have a digital. What are some non-mechanical, like a sundial? That's a clock, or a candle clock. The candle ones. You light a candle, and basically how far it's burned down will tell you how. Okay, so the point is that as we go up the hierarchy, we are more and more abstract. As we go down the hierarchy, we're more and more concrete. And depending on the context, we may want to get even more specific. So this is what the inheritance concept is about. The phrase to remember is a. So in this case, a digital clock is a mechanical clock, and a mechanical clock is a clock. So going up the hierarchy is the is-a. So a digital clock is a mechanical clock. A mechanical clock is a clock. A candle clock is a non-mechanical clock, is a clock. Okay, so inheritance is where in the program, in the software, we take this concept and we say, okay, we're going to have a parent class or superclass or base class. These are all more or less synonyms. And that the derived class we're called child classes or subclasses. Usually, I'll usually stick to superclass and subclass. What the heck was that? What are you doing to me? No, I don't want a highlighter or a pen. Okay. Okay, so now the child inherits the characteristics of the parents, and this is the metaphor is basically asexual reproduction rather than because you don't have two parents, but so the child inherits everything in the parent. So everything that the parent has is inherited by the child. What does that mean in the context of Java programming or object-oriented programming? What is in a class? Methods and data. Methods and data, instance methods, and the instance variables. And those defined in the parent class. So we can take a particular class and we can subclass it and we can add new variables, we can add new methods, or we can modify the existing ones if we are allowed to. And so this was sort of a software we used. This was a big buzz thing back in the particularly 70s and 80s. And it was kind of overhyped. What was the deal? Well, the deal was companies and DoD spent huge quantities, and still do, on writing software. And then when they went to say, okay, we want a better version, we want a better mousetrap, a better piece of software. In most cases, using previous paradigms, they basically had to throw away everything they did and start from scratch. And so the people pushing object-oriented and this inherit, they say, well, hey, wait a minute, you don't have to throw it away. If you have a class and you want to improve that class or make it do something a little different, we can subclass it and then add the additional features we want and modify the features that aren't doing exactly what we want. We can modify them to do something else. So in other words, we're not throwing away everything. We're kind of reusing what we've already done and not reinventing the wheel, so to speak. Now, it was overhyped, but it's still true to a certain extent, but it requires a little more thought than they had. So the idea is that we can use existing software components to create new ones. And we can capitalize on all the effort that we had. In other words, if I have a component and I verify that component and that component works and does what it's supposed to, then if I subclass that, then everything that I'm using in the superclass is still going to be, if not 100% valid, maybe like 90 to 95% valid. Again, I'm not starting from a clean sheet. I have stuff that works. Now, it is still possible to break things that work, but that's sort of okay. So that led to the idea of polymorphism. That's another. This is what I like to call ignorance and apathy. What do you think of the problem of ignorance and apathy? I don't know, and I don't care. So this allows different types of objects to respond differently to the same message. So in particular, if we have a thing and all I know about it is at a clock, and if every clock has a method that says show the time, and it will show me the time that however it has done it, then I don't know or care what type of clock it is or how it's creating it. In other words, I have this clock object, and I say, what time is it? And it tells me. What type of clock are you? I don't know or care. Now somewhere else, when somebody who's configured it, kind of wearing another hat, somewhere I've configured it with the kind of clock that I want, because I may be concerned about how accurate it is or how fine grained it is. But once I've done that, then I can just sort of forget about it and just say show the time. How is that important? Well, because let's say that I'm writing this clock, and I'm also writing something that uses the clock, and those are both happening kind of more or less simultaneously. And ultimately, I want a clock that's going to show me things up to a millisecond. All right, but that's going to take a lot of work. And in the meantime, I have another program that's going to be saying, okay, I need to know what time it is so I can do this other task. Well, what I can do is, let's say that I have an instance of a clock, but it doesn't give me the granularity that I want, but it'll show me the time. So if I just say, okay, this is going to be a clock, I can use that thing that I already have that isn't going to be my ultimate version. I can use that and then develop the other piece that's going to use that clock. And then once I have that working the way I want it, and I say, okay, now I want a better clock, I can now implement that better clock, put that in, and not have to touch the other component. The alternative is, if they are tightly bound, then I need to kind of bolt my application onto that other clock, and then when I want to improve it, I need to kind of, get a cutter, cut that off, and kind of do also. In other words, I need to do surgery on both components in order to improve the clock component that I have here. Whereas with polymorphism, ignorance and apathy, I don't know or care what this is. I can use the clunky clock while I'm developing over here, and then when I get the better one, I can just plug it in and I don't have to touch this other one. What's the benefit of that? Once I've verified this other component, I don't have to touch it again. So it's like editing code is bad, unless you have to. Why do you have to? Well, there are two reasons you have to. One is you need to implement the things that the class is going to do. And then the other is you need to fix it if it's doing the wrong thing. Apart from that, if it's doing everything else right, don't touch it. Okay, so I made it halfway through, so that's not bad. So we'll pick this up again and kind of read ahead in chapter 8 as well, and we'll pick this up tomorrow.